to the beginning junction, right? So this is where we stopped last week. We have finished the derivation of a current concentration, which requires two functions for the integral, right? The first one is Fermi Dirac probability function, which is telling you the chance of the energy states to be occupied by electrons, right? So it is between 0 and 1. The other one is density of states. So these two functions integrate together. We can find the electron concentration in the conduction band and the whole concentration in the valence band, right? So after we know the concentration, the next thing we do to move on is to derive the currents, right? As we mentioned in the past few weeks, the output signal of a semiconductor device is mostly given by currents. So it can be given by pure currents or current density. So here we can see the relationship between the currents and the fields. Right? Field is directly connected to the voltage, which is source of our energy by battery. So if you apply some bias or voltage drop, you can create an electrical field, and this electrical field will drive the current to flow out of the device, right? So you can see the connection between current density and the electrical field is this constant called what? Conductivity, right? So this sigma is conductivity. If we break it down, you can see these are the parameters determining the conductivity. In the bottom denominator is the mass, effective mass of electrons or holes, right? So if the electrons is lighter, it can move faster, right? Creating more currents, right? So the other one is concentration. So N is for the electron concentration, and the Q is the charge carried by every single electrons, right? So this is how it's going to learn, right? So actually, this is the way of Ohm's law, right? Another way, right? So the most common one, most of you may be more familiar with this way of writing Ohm's law, which is the relationship between current and the voltage divided by resistance, you got current. So this is what we learned by the Ohm's law. This is another way of writing it because you can convert this current into current density and the voltage into the electrical field, right? We will show you later, right? So today we want to show this Ohm's law actually come from the origin of Newton's second law, right? I believe most of you have learned Newton's second law, Newton's first law, and Newton's third law when you were in high school, right? So this is related to each other. So why? I hope you can have some sense of these two equations. Ohm's law comes from Newton's second law, right? Which one is better? Newton's come first or Ohm's come first? 牛顿跟欧姆哪一个比较好？Newton, right? Newton is in 16th century. Ohms is in maybe 19th, 18th century, right? So, do you know why? Because Newton first described how the particle is respond or react when you apply certain force from outside, right? So usually this particle will change its momentum when it is receiving some force, right? That's how Newton's second law told us, right? So the basic equation for you to understand Newton's second law is the change of momentum is equal to force, right? Force. Right, so this is Newton's second law, right? right? Force can change the momentum of particle, right? So this is helping you, or a starting point for you to understand how can you create a useful electrical currents by electrical field, because field is a certain type of force, right? Fields, electrical field, in time. What is the definition of electrical field? It is the force fields by fields means applied to, right? Applied to each fields by each unit of charge. Okay? So mathematically, you can say it is of the unit of Newton per Coulomb. 单位电荷受到的力叫做电场。Okay? So that's the origin of electrical fields. 好，电场的意思就是每单位电荷所受到的力。所以这个力呢 will be applied to the electron. How many charges are carried by an electron? You know, each electron carries, for each electron, the charge is 1.6 10 to the minus 19 Coulomb, right? So if you multiply electrical fields by the electrical charge, which is shown here, electrical field and the electrical charge, that's the total external force applied to a single electron, right? But we don't only count one electron. We are counting so many electrons. How many? The total number of electrons within a unit volume, right? So that's why we need electron concentration, which is of the unit of the total number per unit volume, right? So if you look at the electron concentration, which is of the unit Cm minus 3, right? That's the unit of a volume, right? So this equation can tell you the physical meaning of the electrical currents, right? So how can we go from here to here? The key parameters is this guy, tau. Tau is of the length, mean free time. Okay, 平均自由时间. We will tell you what we mean by mean free time. So imagine you have many electrons inside a semiconductor, and without any electrical field, each electron will travel in a very fast velocity. And this velocity can be as high as how much? 1.6 10 to the 6 meter per second. 每秒160万公里 super fast, right? But these fast electrons are useless. Useless means they cannot contribute to any useful currents. Why? Because all the electrons are running in different directions. There is no uniform directions for all of the electrons, right? Until or unless you apply a certain electrical charge, no, you apply a certain electrical field by voltage, forcing all of the electrons running in the same direction. That is how we create a useful electrical current. So when the electrical field is applied to the group of electrons, all electrons will run in the same direction that is opposite to the direction of electrical fields, right? Because the electron is negatively charged. So it is in the opposite direction to the electrical field. The electrical field in this direction, electron will run in that direction, right? So this is the useful signal. We call it group velocity because all the electrons are moving together in a certain group of velocity, which is much slower than the phase velocity, right? So group velocity, here's the example, so slow, 2.8 times 10 to the minus 4, okay? So it is a factor of 10 to the 10th, right? 10 orders difference. 一个是10的6次方，一个是10的负4次方，超级慢。Okay, but this is the useful information because this group motion of electrons can make useful currents because they are running in the same direction due to the force from the voltage, right? So this is how we start to derive Ohm's law, right? So here, feel the difference. Without force, randomly motion. With force, uniform motion. 一个是混乱的，大家乱动，因为这个是受热造成的一结果，所以把电子的移动没有方向性，对不对？直到你把它用一个电压去驱动它 ，right? So imagine if you apply a certain force to the electron, according to Newton's second law, this can be write as F equals ma, right? M is the mass, 质量, right? What is A? Acceleration, 加速度, right? So when you apply a certain acceleration to a particle, what is the result? This particle will move faster and faster. Right? That's what acceleration do. It's the 加速, right? Until it hits something and slow down. Otherwise, it will increase the velocity into infinity because nothing is to stop it. 对不对？当一个加速中的粒子没有受到任何阻挡的话，它的速度会变成无限大，因为它是一直加速啊，对不对？对，就像你开车一直踩油门，都不踩刹车，也不放油门，这就是越冲越快，对不对 ？Okay, so imagine if you accelerating the group of electrons. These electrons will move in with the increasing speed, increasing velocity, until something happened, slowing it down, right? So this second force, other than the electrical field, will stop the electron to make the kinetic in steady state. It's in steady state, okay? 好，在稳态的时候。In steady state, the currents or the electrons, many electrons are moving with a constant velocity. How come the velocity will become a constant? It must happen when you reach balance, right? Balance means you have two forces applying to the same particle, but these two forces are in the opposite direction. So one is to accelerate the electrons, the other one is to slow down the electrons. When these two forces are equal to each other, then you have a zero net force. So in this situation, electrons are moving in a certain constant velocity, right? So what is the second force to slow down the electrons? Okay? So this is the second slowing down force, collision or scattering, right? So the second force. The first force, of course, is from the voltage creating the electrical field, right? The second force to slow down the electron is collision.碰撞 or some people will say scattering, right? 散射。Collision with what? Let's say 碰撞。Okay. Collision to each other. Okay, because each electron is of a certain mass, right? So we are moving in a very fast velocity. Two electrons will bump into each other. When the collision happens, the speed will slow down. The second possible force, or the second possible source for the collision is the electron can run into atoms, right? Can run into the proton, which is positively charged, or some defect inside the crystal, right? So you can bump into the other electron. You can also collide with the protons, which are vibrating all the time because you are at a certain temperature. 我说原子它在有限的温度里面，只要它不是绝对零度，它会在原地一直热扰动 ，right? As long as the temperature is not absolute zero, you will have a more or less certain vibration of atoms. These vibrating atoms will sometimes stop or collide with the electrons because it is constantly moving around a certain atomic position, right? So this collision is unavoidable when you have a lot of electrons moving in a certain direction. So these are the second force, right? So what do you mean by the mean free time? What is the physical meaning or the definition of a mean free time? Okay, as I put here. Okay, mean free time is the average time that an electron undergoes no collision. Here is the definition. Tau is the average time that an electron undergoes no collision. So it is called free. When you have some collision, it's not free because you are stuck. You change the traveling direction or change the traveling velocity because of a certain force applied to you, which means you are not free. So between two consecutive collisions, the electron will be accelerated for a certain time. This certain time, on average, is called tau mean free time. Mean 就是 average， 对不对？平均自由时间就是 you can imagine a certain electron will be constantly bumped into different particles. So in two consecutive collisions, you must wait for a certain time. So on average, the time in between two collisions is called mean free time. 这样知道吗？平均自由时间就是在两次的连续碰撞之间所等待的时间。有的电子可能1秒就碰撞一次，有的电子可能是2秒，有的电子可能是10秒，对不对？所以所有的电子的碰撞时间，把它加起来，再除以所有电子的数量，就是它的平均碰撞时间。 这个平均互动时间就叫做 mean free time. So in other words, during this mean free time, there is no collision. That is the reason we call it free. Right? Free is meaning the electron can be accelerated by the electric field without any collision. Okay? So that's the assumption created by a scientist called Drew. Okay? So this comes from the Drew the model. Okay? 这是一个假设 ，OK， 一个物理模型 ，OK，proposed by a scientist called Drew, OK， it is reasonable, so people use it to describe the electron motion inside a semiconductor. So now we have two forces. One is to make it running faster, to make the electron run faster. The other one is to make the electron slow down, right? So how do you balance these two forces? Okay, so we need to write it down. Right, so in the first red box here is the description, is the equation of Newton's second law, which is telling you the momentum change is equal to the force from the electrical fields, right? So that's the equivalent description from the electrical field, and this is the momentum change. So you must understand the three parameters: electrical field, charge, and the electron concentration. Right? So this negative is from the Q, describing the negative charge. Right? So this negative is to tell you the force is in the opposite direction of the electrical field. Right? Okay. So I put here Newton's second law, right? So this force got to be equivalent to the collision, right? So here we introduce a ratio or a probability given by the first red box in the top, right? So what is this? T divided by dt divided by tau. That's a ratio without any unit, right? Because you are dividing time by time， 时间除以时间，所以是没有单位，因为它是一个比例。Okay, this is a ratio. So this ratio is of a certain important meaning, right? So that's the probability that any electron has a collision in a time interval. dt means a small interval of time, right? So this small interval of time is something like you do calculus, right? 你把时间切成一个非常微小的单位时间。This delta t or change of t is compared to mean free time, right? So statistically, 统计上来说 every tau will have one collision, right? On average, for each electron, right? So if this delta t is large enough to be the same as tau, what is the probability that the electron will go into a collision? 1, right? When dt equals to, so this is the time of electron acceleration, but the acceleration time is the same as the mean free time. That means in statistics, 在统计上面来说 this electron must run into a collision, which will stop the traveling. Okay, so this is an important assumption, important concept you got to understand before moving on. Okay, 可以理解吗？ 哦，你就想说一团电子一直加速，然后呢，平均来讲，每团电子在经过10秒之后就会产生碰撞。哦，所以平均来说，不是统计来说，t 等1秒的时候，它碰撞的几率就是1/10；2秒的时候，碰撞的几率就是2/10。它加速的时间如果越长，它产生碰撞的几率就越大。Right? So this is the probability for an electron to run into the next collision. It is proportional to the time of acceleration. Making sense, right? So when the acceleration time is long enough to make it the same as tau, then the probability of collision is 100%. Right? So when the collision happens, momentum will change, right? Because you change your velocity, right? So the second gray box is the amount of momentum change. So D is short for delta. 就像我们积分的微分，对不对？积分 d dt is the delta p delta momentum, right? Equals to what? Given by total momentum, assuming it is moving in the x direction, times to the ratio of collision, right? Right? So this is telling you when the collision happens, the total change of the momentum is equal to the original momentum, which is an assumption. Okay? Some collision may not fully stop the electron. Some collision will change the electron moving in the opposite direction. So on average, we use or we assume the total change of momentum after one collision is the original amount. 假设它原来的动量是 p of x， 产生一次碰撞，在统计在平均上来讲，它就是最大的变化量。平均来讲就是原来的动量。Okay, so this is what the equation is telling you. Okay, so you got to imagine what happens when a group of electrons are traveling at a very fast velocity. They will undergo many collisions. For each collision, on average, they will change the momentum of px, right, which is the original momentum given before the collision, right? So you move the dt to the same side of dp, so you will get the derivation of the momentum is equal to px divided by tau, right? 这就是一个微分的结果，对不对？ Right, so as I put in the slides, okay. So, see, why do I put this way? Because this is another way of momentum change due to the collision described by tau. So, this is the second force. Right? The first force is by electrical field. The second force is by collision, described by tau and the p of x. That's the purpose we write in this way. Because we know in steady state, these two forces got to be the same in order to make the electron running in a constant velocity, not slowing down, not speeding up, okay, because the two forces are in balance. One is counterbalanced by the other, right? So in steady state, as I put here, see, in steady state, the two forces got to be equal to each other, right? The two forces, this is the first force due to electrical fields. This is the second force due to collision. So the first force is described by the electrical fields. The second force is described by the tau, right? So pay attention and understand the sign of a negative, right? So this negative comes from Q. This negative comes from smaller, right? Smaller than the original value. Comes to the decrease of the momentum. So it is in the negative sign, right? So you add these two forces up, and the sum got to be 0。对，两个力的平衡就是相加等于0，可以理解吗？一个是电场来的加速力，一个是碰撞产生的减速力，对不对？当加速的力量等于减速力量达到平衡的时候，我们就说它是一个 steady state 稳定的状态，不管你是稳定的前进还是稳定的停止。Right? When you reach a steady state, you have a 0 net force. So when this happens, the particle will keep moving in a constant velocity. It will not change the velocity. When the particle is originally at a start state, it will not move because there is no net force, right? So this is the key to understand the dynamic inside a semiconductor with two forces. When you apply a certain voltage to the device, right? You got to have two forces, electrical field and collision. The rest thing is to arrange it in a clear form. 剩下就是基本的代数而已，移来移去的 ，OK？ So if you understand the equation in the bottom, the next following steps are easy. You just move the terms into one side. Okay? So I hope you can understand these slides. Okay, if you have any questions, come see me. Okay? So after the arrangement, we can know the relationship. Okay? So this is what we got after the arrangement. 当你把这些常数都整合在一起的时候呢 ，OK？ So here we can see, you see the bracket. 就是那个挂号中挂号 brackets is put outside the momentum, which is meaning average momentum. OK， 平均的动量。The average momentum of each electron is given by P of x divided by n. See？ 因为 P of x 就是单位体积里面的总动量，对不对？单位体积里面有几颗电子，就是 n 个电子 ，right? So you have a total number of n inside a unit volume. So this total number of momentum, when it is divided by the concentration, it is giving you the average momentum of each electron. And then you know momentum according to Newton's second law, momentum equals mv, right? 就是高中的物理嘛，动量等于质量乘以速度 ，right? Mass multiplied by velocity is momentum, right? So after the arrangement, you can see the momentum equals what? Minus Q tau. Right? So this is what you see on the slides, right? So why do we need to write this way? 为什么要这样子写？ Because we can see velocity here. We need velocity in order to quantify the electrical field, right? We need this guy. Velocity is important because velocity can make you evaluate the electrical field, right? Electrical field, no, electrical current, sorry. Electrical current, Q, N, V, right? You have V here. So this is the reason we need to equate, and V equals minus Q tau psi delta X, right? So after you put effect max here, you see the remarks given in the slides, right? This is a very important equation, right? So, as I put here, so this means average velocity in the x direction for each electron. Okay, average velocity of each electron is equal to what? Equal to this guy momentum divided by mass. So this is the effective mass, right? Effective mass, which is the mass of electron in a certain crystal or certain semiconductor. It is related to what? To the electrical fields, right? Minus Q times tau times electrical fields. So the total ratio given here is of a very important name. We call it what? We call it mobility. Okay? So you can Google mobility of a certain semiconductor. It is the key parameters for you to evaluate the performance of how fast the device is responding to the input bias. Okay, so in summary, velocity is proportional to electrical field with the constant of mobility.哎，这个就是很重要的一个公式，因为它告诉你，当我一个自由电子受到电场的影响的时候，它能跑多快，由谁决定？由 mobility 的决定 ，right? Because this electric field can be a constant. It is only determined by the voltage applied to the device, right? For example. If you made the device by two material, okay, and you apply the voltage to that device with a p-n junction, so you know the IV curve for p-n junction will go like this. V I I， 你在量那个 IV curve 的时候，不就是看这个图吗 ？Right? One device is given by this green line, and the other one is given by this yellow line, right? Which means when you apply the same force, V is the same, right? V1, when V is the same, which means electrical field is the same. Under the same bias, the two devices will produce two different currents. Why? It's all because of this guy. This device is of large velocity, so it can give higher velocity. Large mobility give large velocity, right? So velocity again is equal to current by this equation. Q_V equals. Right? So if you can make the electron run faster, you can produce higher currents. How can you make the electron run faster? That is how you control the mobility of the electron. You can make the effective mass smaller, right? Also, you can make the tau longer. You cannot change Q because Q is a constant, right? It's determined by electron charge, 1.6 10 to the 19。只有 Q 不能动而已，对不对？你可以让它的质量变得小一点，或是让它的碰撞变得少一点，加速的时间就长嘛，对不对 ？So these two parameters is how you to improve the velocity of electron. If you can make it run faster, you can make a high-speed circuit. OK， 这样哦。所以高速的电晶体 the high-speed device or RF device, right? Radio frequency. Radio frequency, right? RF device or RF IC, RF circuits is usually made by the material with high mobility. You got to choose the right material to make the right ones. Right? Do you know what's the typical semiconductor used to produce RFIC? What's the typical semiconductor? You have a first generation, second generation, and the third generation. 对不对？有没有听过第三代半导体、第二代半导体、第一代半导体？Let me see. Okay, I put the slides. Okay, so here you can see the figure showing the velocity as a function of electrical fields, right? So the slope velocity as a function of electrical fields. The slope is mobility, right? So if you have a larger mobility, in theory, you can have a higher velocity. So here we see the results of silicon, gallium arsenic, and silicon carbide and gallium nitride, 4 materials, right? So usually the RFIC is made by gallium arsenide. Mostly, you can check the mobility of gallium arsenide and check the mobility of silicon and check the mobility of gallium nitride or silicon carbide. Gallium arsenide can produce higher mobility than silicon, than other materials. So we call this a second generation semiconductor. 第二代半导体 is referring to high speed semiconductor, high speed mobility. Okay, silicon is the first generation is for high density. Okay. First, if we first, second, and the third. Okay, silicon. Second generation is usually referring to gas, right? Third generation is called referring to gallium nitride, right? So this is for high density. You can make the device super small. Second generation, when you have a more and more cell phone, you need to download movie in a very short period of time. You need to respond the data very fast. So it is for high speed. High speed, okay? 高速, right? Now we come to the third generation. High what? High density, high speed, and then high voltage or high power. Why do you need high power or high voltage? Because you want to charge the car faster. We don't want to wait so long. If you use high voltage IC or high voltage material, you can charge the battery with a shorter time, right? It is not that important 10 years ago. If you have more cars, more and more cars driven by battery, you need to charge the battery without waiting too long. Then you need to charge it with a high volt to reduce the waiting time. If you made a device by silicon or by gas, you can destroy the device with high voltage, right? So usually, how can you make the device survive in the high voltage operation? This is large band gap. You need to choose the semiconductor with large band gap in order to survive on the high voltage operation. We'll tell you later, okay? How do you make it run faster? How do you make a high-speed device? You need to choose the semiconductor with large mu. This guy. Why? Because you want to make the electron run faster under the same voltage you apply, right? So you can download the movie faster. You receive the signal and send out the signal with a shorter time. You can communicate with higher speed, right? Okay. What is needed for silicon? Why can you make a silicon high density device? High what? Large what? Large amount of money. What do you mean? It is very expensive to make a device small. So you need to spend a lot of money buying the lithography machine, like we heard last Friday, right? If you go to the seminar, you know, right now there's only one company in the world making a lithography, allowing you to make the device below 10 nanometer, ASML, right? That is a burning money business. You can also make the device small with gas, also with gallium nitride. The problem is that nobody will buy it when you make it small. You don't see the motivation, you don't see the market, but people will pay a lot of money to buy the device by silicon with so small dimension. Okay, why? Because you need a super power computing power for artificial intelligence, right? Silicon is the most mature semiconductor industry, but it is still thriving. Why? Because you see more and more application coming in every decade, right? Silicon 是最成熟的半导体，可是它也是最贵的半导体。为什么？因为 Silicon 的这些制成的 facility 设备全部都是50年以上累积出来的设备，越做越精密，越做越贵。为什么它要越来越小 ？OK， this come later, this come the latest. OK, so most mature, this is the second mature, this is the least mature, so you don't need a fancy facility to make it small. Just make it working will make you a lot of money. Okay, so that's how we need different types of semiconductor for different applications. You cannot choose only one material for all kinds of applications because they are different according to this figure, right? So it is showing one scenario when you have a low fields. Low fields means low voltage, right? So on the low fields, which one is running fast? See, gas shooting the highest velocity when the electrical field is not large, right? But when you keep increasing the velocity, gas will go down in the velocity. So when you have a very high voltage in operation, you need to choose the third generation with a large band gap in order to shoot for high velocity. That's the reason for third generation semiconductor. Okay, let's take a break.